Alright, let's talk about our new SunPower solar PV system that we just had installed yesterday. Today is Wednesday, August 19th, 2015. It is 12:30 in the afternoon. It is a nice bright sunny day, couple puffy clouds out, but for the most part it is just ideal conditions. The system was just installed yesterday. It's been running for exactly 24 hours. The system was turned on yesterday at about 12:30 in the afternoon, and it's now 12:30 in the afternoon the next day. So this is a SunPower 9.38 kilowatt system consisting of 28 panels, and they are the 335 watt X21 black SunPower panels. These are extremely efficient panels. We are really happy to have them, and we expect them to serve us for many years to come. So why don't we go up and take a look at the meter. We'll see what it's doing right now, and then we'll go inside and check out the inverter board. Alright, and here we are at the outside utility meter. Apologize if this is fuzzy at all or if it's hard to read. It's extremely bright and sunny out, and so there's lots of reflection, but I think you can just see that the arrows, or I should say the ticker marks, are moving right to left, which indicates that the grid is currently receiving power from us, and that's why it says received. It's not that they've received 1,235 kilowatt hours from us, not yet, not in one day of course, but so their nomenclature is a little off, but it's this received or delivered is from the frame of reference of the utility. So they are currently receiving power from us, and as you can see, those tick marks are moving pretty fluidly from right to left, and so they are receiving power from our panels. Now let's go inside and we'll take a look at the inverters. Alright, so now we are in the basement. We're looking at the inverter board. This is a great layout here that our installer has done, and you'll notice we have two inverters. These are SunPower branded SMA inverters. These are the SMA 3800 TL US inverters. And the way our system is designed is the 28 panels that are up on the roof are arranged in 4 rows of 7 panels, and each row is its own string. And we did that for purposes of, we do have some shade issues with the surrounding trees in the early morning or in the extreme late afternoon or early evening, and we want to make sure that we mitigate as much of that as possible. Even though those aren't optimal solar gathering times, still you want to maximize where you can. Really happy that our installer decided to go with two different SMA, two separate SMA inverters. Each has 2 MPPT trackers. That way we're maximizing each string. So why don't we go in and look close and see what they're putting out right now. We're basically at solar noon, and what's really cool is these inverters don't have any buttons on them because they are outdoor rated, and you want to make sure that water and whatnot couldn't get in, but you can still control the screens and what they display simply by knocking on the case. So I'm just going to knock right on the black part of the case there, and you can see it lights up. And so these are absolutely putting out their maximum power right now. It's solar noon on August 19th. These inverters are rated on the AC side to put out 3,840 watts. And you can see they are basically doing all of that. So really happy with how this system is performing right up to spec. You can see today it's created 15.38 kilowatt hours, and the total since this inverter was turned on, which has really only been 24 hours, it's created 0.03 megawatt hours, or in other words, you do the math, 30 kilowatt hours. So that's in one day by this one inverter. But we now have a second inverter that is controlling the other two strings, and if I knock on this, you can see this one's also maximizing itself. We got 3,838 watts currently coming out of it, 15.32 kilowatt hours, and also 0.03 megawatt hours total since this inverter was turned on yesterday. And you can see down below here, the displays go back and forth between each string, saying what the voltage is and what the amps are for each string output right now. And then this symbol is obviously meant to represent this actual inverter. And then here's the stats between the inverter and the grid. It's saying what the amps and the volts are that it's reading off the grid for the grid voltage, and then how many amps we are currently pumping out into the grid. So this particular inverter right now is putting out about 15.5 amps. Yeah, 15.6. And if I come back over here, this one's also putting out 15.6. So right now we are putting better than 31 amps out into the grid, and really happy with how these are working. So the silver, the metal conduit, is where the DC comes in from up on the roof, goes into this wiring box, and you can see the DC goes up into each DC disconnect. So if we had to shut down, we could just turn the knob and shut down the solar system on the DC side. The blue lights you see there are actually lightning arresters, one for each string. And then the plastic PVC conduit is the AC electricity coming down that's been made. It goes down into this combiner box, which is a way also of disconnecting the AC side. And from there we go over into our PV meter, and you can see we're reading 60 kilowatt hours have been created in just barely over 24 hours, about 24 and a half hours. So really excited with how this is performing right out of the gate. We just really couldn't be more pleased. So big shout out to our installer, Hudson Solar. Highly recommended. They did a great job, and we're really happy with our system. Hope this has been helpful for you. Have a great day.